Well, here are the answers to quiz number 2. And remember that these questions correspond to version A. And so you'll have to find the questions on version B, and I'm sure it's not that difficult if you look at the questions. Alright, question 1. There we go. Question 1 talks about an object moving 15 meters to the north and then 11 meters to the south. So to find the distance traveled, you got to go add up both. It's going to be 26 meters. While to find the magnitude of the displacement as shown in the diagram, you see that displacement is from A to C. So while the distance is just the sum of the two, displacement is from the starting point to the finishing point. So it's 15 minus 11. That is going to be 4 meters to the north. So actually the displacement is going to be this much, 4 meters to the north. Well, in the second question, the car travels 90 kilometers per hour. And how long does it take? So you got to find the time for it to travel 400 kilometers. You may keep the units in kilometer per hour and kilometers in this case and get the answer in hours. That's one way to do it. And the formula here is displacement is the product of velocity and time. Or velocity is displacement by time. And rearrange that to get time as the subject. You get 4.4 hours. You get it in hours because of the units, kilometer per hour and kilometers. Alright, now question 3. You're driving at 72 kilometer per hour and you look to the side for 4 seconds. How far do you travel during this inattentive period? Now, you should not be inattentive ever while driving, because at this speed, even for 4 seconds, you're going to be moving a big distance, as I'm going to show here. The velocity is 72 kilometers per hour. You change it into meter per second, multiplying with 5, dividing by 18, and you get it as 20 meters per second. And time is 4 seconds. Displacement is just the product of the two, because when you rearrange, displacement is going to be 20 times 4.0, that's 80 meters. In just 4 seconds you've traveled 80 meters, which is a big distance. Now number 4, you're driving home on a weekend from school at 55 miles per hour for 110 miles, I mean. So that's the question. Then it begins to snow, and then you slow to 35 miles per hour. The total time that you take to reach home is 4 hours and 15 minutes, and you got to find the distance. So you're driving for 100 Oh, did I miss the 4th question? I think I missed the 4th. Let me finish the 5th first. This question is about an airplane increasing its speed from 100 meters per second to 160 meters per second. So I kind of missed the 4th one. I'll come back to it later. Here the initial velocity is 100 meters per second. The final is 160. And the acceleration is 15 meters per second squared. How much time does it take? The equation that has all the 4 terms is A is Vf minus V0 by delta T. Rearrange, and you get this equation, into which you substitute, and you get the answer as 4.0 seconds. Now in the 6th one, the car starts from rest, accelerates at 4 meter per second squared for 5 seconds, and then maintains that velocity for 10 seconds. And after that, it decelerates at the rate of 2 meter per second squared for 4 seconds. What is the final speed? So there are different cases here. Initial velocity is 0, the acceleration is 4 meter per second squared, and that is for 5 seconds. And we can find the final velocity after this period. That's case 1, and use the equation for acceleration, which is Vf minus V0 by delta t. Cross multiply, make Vf the subject, you get this. Plug in the numbers and you get 4 times 5, which is 20 meter per second. Now in case 2, it maintains this velocity for 10 seconds, and so that doesn't matter because you only have to find the final speed. And then after that, it decelerates at the rate of 2 meter per second squared. So the initial velocity is 20 now. A is negative 2 because it's decelerating, and the time is 4 seconds. Got to find the final speed. Again, use the same equation. Substitute the numbers, and you would get 20 plus times minus is negative. So you get 12 meter per second. In the 7th question, initial velocity is 5 meter per second and experiences a constant acceleration of 2 meter per second squared. What is the cart's displacement during the first 6 seconds of its motion? So, initial velocity 5 meter per second. Acceleration is 2. And you got to find delta x, and the time is 6 seconds. Now, the equation that has all these 4 terms is delta x is v naught t plus 1/2 at squared. So when you substitute the numbers, this is what you get. When you calculate them individually, you get 30 for the first term, which is this, and then you get 36 for this term. So when you add them up, you get 66 meters. In the 8th question, the initial and final velocities are given. Initial is 40 meter per second, the final is 80 meter per second, and the displacement is 200 meter. You're asked to find the acceleration. Now here the equation that has all these 4 terms is Vf squared is V naught squared plus 2a delta x. Rearrange that to make a the subject. Get Vf squared minus V naught squared by 2 delta x. And when you plug in all the numbers and calculate, you get 12 meter per second squared, which is the acceleration. In the 9th question, an object is moving in a straight line with constant acceleration. Initial velocity is 16 meter per second. 3 seconds later, it's traveling at 10 meter per second. How far does it move during this time? So you have the initial velocity, you have the time of movement, and you have the final velocity. You got to find the displacement. There's no mention of acceleration here, and so the equation that has these 4 terms is this one. Displacement is average velocity multiplied by time, and when you plug in the numbers and calculate, you get 39 meter as the answer. In the 9th question, that was the 9th. Now the 10th question, a ball is thrown down from the top of a building with an initial speed of 25 meter per second. It strikes the ground after 2 seconds. How high is the building? So the initial speed is 25 meter per second. A is 9.8 meter per second squared. The time is 2 seconds. You got to find the height of the building. In this case, the height of the building is just the displacement. So you use this equation. "25 times 2 plus 1/2 times 9.8 times 2 squared." And on calculation, you get 69.6 meter, which is approximately 70 meter. Now to do the fourth one, which I had forgotten. In this question, you have been driving for 110 miles at 55 miles per hour. So you can find the time for which you've been doing that. That's 2 hours. And since the total time is given as 4 hours and 15 minutes, and you know that's going to be 4.25 hours, because to change the minutes into hours, you divide by 60. So 15 divided by 60 gives you 0.25. So the total time is 4.25 hours. And therefore the time for which you're driving at 35 miles per hour is 4.25 take away 2, which is 2.25 hours. Therefore, the distance traveled during 2.25 hours is the velocity that you had, which is 35, multiplied by 2.25, which gives you 78.75 miles. Now, so in the first part you were driving for 110 miles, and in the second 78.75. So the total distance is 188.75 miles. Taking significant figures into consideration, you get 190 miles. So that is quiz 2. And again, as I reminded you, there are 2 versions on the quiz, and you need to try to match the questions. I'm following version A. And if it's version B that you have, you need to figure out which question each one is before you look at the answer. Thank you.